Hello, you are welcome to this session. It is session 5 of Unit 1 of Pedagogical Content Analysis in Chemistry. And this session, you remember in the previous session, we started with the types of chemical reactions, and we even looked at combination reactions. So this session is specifically looking at displacement and metathesis reactions, which is the double displacement reaction. So let's continue. Okay, let's look at objectives for this session. We'll distinguish between displacement and metathesis reactions. We will write equations of displacement reactions, and finally write equations of metathesis reactions. So these are the things that you should be able to do after going through this session. Let's look at our first objective, that is displacement reaction. It's a reaction in which an element reacts with a compound and the element displaces a second element from the compound. In other words, in such reactions, you will have one element standing at one side and then reacting with a compound. And as the name goes, there is a displacement. So you would have that one element going into the compound and displacing one element out of the compound. Then it will take the place of that element. So at the product side, we expect two products. Displacement reactions have the general form A plus BC going into AC and B. So let's look at this very well. A has come to take the place of B. In other words, it has come to displace B and it has taken its place. And so at the product side, we have AC plus B. So B has taken the place of A. Unfortunately, this is a reaction that proceeds only in the right direction. So we don't expect B to displace A back to retain its position. For such reactions, what you need to be very successful is the activity series of metals. Simply because it's not in all reactions that if you have A plus BC, A is going to displace B. So you need the activity series, and I'm referring you to it. Go and then get it, look at it, and that will be of much help. Let's look at the types of displacement reactions. One is an active metal reacting with an acid. This is a displacement reaction. An example is what we have there. Zinc metal reacting with hydrochloric acid, which is the acid, to give us the zinc chloride, which is salt, and hydrogen molecules, the gas. In this reaction, the active metal, zinc, has displaced the hydrogen, and we now have hydrogen standing alone, but since it's a diatomic molecule standing alone as a gas, and then we have zinc chloride, which is the salt. So this is a method that you can use in preparation of salt, and you can also use in preparation of hydrogen gas mostly. Why did we say active metal? Now, on the activity series, not every metal would displace hydrogen. So once again, get the activity series and go through. For example, if we replace the zinc with gold, then we don't expect a displacement reaction. in a case like this to take place. So we don't expect hydrogen gas to be produced. That means that when you pour hydrochloric acid on gold, you don't expect hydrogen gas to be produced. Another example is magnesium reacting with sulfuric acid. There is a displacement here. Magnesium displaces the hydrogen, so that at the product side we have magnesium sulfate and then the hydrogen gas. Another type of displacement reaction is when a metal reacts with a salt. So an example, we have copper metal reacting with silver nitrate to give us the copper nitrate and then the silver metal. This is also a displacement reaction. Let's look at it carefully. Silver has left for copper to take the place. So at the right side, at the product side, we have copper standing alone. We have silver standing alone and its place taken by copper. Another is iron metal reacting with copper sulfate, which is a salt. So the iron takes the place of copper, and so we have iron sulfate, whilst the copper is emancipated from the compound, so it is standing alone. A third type is when a halogen reacts with a halide salt. For example, we have chlorine gas. Now chlorine is a halogen, but it is existing as a diatomic molecule, chlorine gas. And then we have sodium iodide. The iodine is the halide. The iodide is the halide. So in this case, do we expect a displacement reaction where chlorine now takes the place of the iodine and we produce the salt sodium chloride, and then iodine now stands alone. Let's look at the next objective, which is metathesis or double displacement reactions. So this time around we are going to do double displacement, not just one. For what we have looked at, it is just one element going to displace another element in a compound. Here we expect two displacement, double displacement. But what is a metathesis reaction? It is a double displacement reaction that usually occurs in aqueous solution. By this we mean a solution whose solvent is water, and they also have the general form AB plus CD, but at the product side we would have AD and BC. So here there is a double displacement. A goes in for the D as 1, and then B goes for the C. So we have a double displacement over here. We can talk about two types of double displacement reactions. Those are the precipitation and neutralization reactions. So let's look at these two reactions individually. Precipitation reaction first. In precipitation reaction, basically two compounds which are water soluble react to form two new compounds. Mostly you have two soluble salts would now react and produce products in which either they are all not going to be soluble or one of them is going to be insoluble. So the one that is insoluble would precipitate out or would form the solid out. So you would see the solid in the solution. An example is silver nitrate reacting with sodium chloride. We get products which is silver chloride and sodium nitrate. In this case, sodium nitrate is soluble, but silver chloride precipitates out. Another example is barium chloride reacting with potassium sulfate. Now these will come together to produce barium sulfate, which is insoluble, and potassium chloride, which is soluble. So these are examples of precipitation reaction. You can look out for more examples. The next to look at is the neutralization reaction. When do we say neutralization reaction has occurred? That is when we have a reaction between an acidic compound and a basic compound to form salt and water. Take note of the product. We expect to produce salt and water only. When there is another product to it, then that is not a neutralization reaction, because in a neutralization reaction we expect salt and water. In the neutralization reaction too, we can talk about types. One is when we have a reaction between an acid and a base. And a common or a popular example when it comes to neutralization reaction is sodium hydroxide reacting with hydrochloric acid to produce sodium chloride and water. Interestingly, most of the time students think that this is the only neutralization reaction. So whenever you mention, oh, it's hydrochloric acid and sodium hydroxide to produce sodium chloride and water. Of course, it's an example, it's one of them. So our products are salt and water only. Another is a reaction between metal oxide and an acid. So an example is calcium oxide, which is basic, reacting with hydrochloric acid. We are going to produce salt, which is calcium chloride, and then water as the only products. Another is where we have sodium oxide with nitric acid, which will produce sodium nitrate, which is the salt, and then water as the only product. My good friends, that's where we end the session. And you have these questions to try. We'll meet again in the next session. In the meantime, thank you for having me. My name is Robert Chumesi.